Hey guys, today I'm going to review with you systems of linear equations. And I say review because this is a Math 1 concept. And so what we do is we review it and then we kind of put a little spin on it when we talk about systems of nonlinear equations. And we solve those the same way. We can graph them, we can use substitution, and we can use elimination. So those things should sound familiar to you. So first we're going to start off with just working with linear equations. And so you'll need some paper so you can jot some of these notes down and some examples. So we're going to start off by what is a system of linear equation? Systems of linear equations. So what you're going to have is you're going to have two or more, and in this class we only look at two linear equations. I'm starting to write what I'm saying here. In Math 3 and beyond, you start looking at systems of three and more, different types of equations here. So I'll say two or more, but in here we only practice with two. Two linear equations graphed together on a single coordinate plane. And with systems, we can solve them graphically, or we can use substitution or elimination. And we're going to do graphically with technology. In other words, we're going to graph it on a calculator or graph it on Desmos, and that way we can find that intersection. But we also need to be able to solve these things algebraically using algebra. So I'm just going to give you guys the three different situations we can have. You can have two lines that intersect at a point, and of course two lines can only intersect at one point. They can never have two solutions. So they can intersect at one point, so it is said to have one solution. And to name that solution, you write that answer as an ordered pair, like 5, 4 or -3, 2, wherever that point is located on the coordinate plane. And we can do that again graphically, or we can do it algebraically. You have parallel lines, and they never intersect, so this has no solution. And of course that can be represented with a 0 and a line through it. Then you have what appears to be one line, but there's really two equations there, and the equations are identical, and so it makes it look like there's one line, but they're actually graphed on top of one another, which means they intersect everywhere. So that's infinitely many solutions. And again, this should be a review of last year. So hopefully it looks familiar to you. And once we start solving this using substitution, it should make, the light bulb should cut on and you should be like, oh yeah, we have done these. So I'm not going to do very many examples, but I'll do some. So that way your assignment on Delta Math, you'll be able to do the different types of equations that are given to you. All right, so like I said, you can do this graphically, but today we're going to practice doing this algebraically using the method called substitution. And so, yes, you can definitely get one solution. You can get no solution. You can get infinitely many solutions, even using substitution. All right, so we're just going to jump into some examples here. I'll just do a few, and hopefully that'll be enough for you to be able to figure out the practice problems. All right, so the first example, I'll do y equals 6x and 2x plus 3y equals -20. And so what we're trying to do here is we are going to solve this without graphing it. And I know we could pull up Desmos, pop these things in, and boom, you get your two lines and you can figure out where they intersect. But unfortunately, you can't use a calculator on everything. And so you have to know how to do this algebraically. And that's why it's really important when you guys do your work this week that you show your work. Can you check it on a calculator? Absolutely. But I want to see the algebra behind your answer. All right, so what we're going to do is you always look for one of the equations. It needs to have an x equals or a y equals. So you always want to make sure that one of your equations is either a y equals something or an x equals something. And that way we can put a box around what it equals. And then you would plug that box into the other equation. And then after you've plugged that in, you would solve it for whether you have your x or your y's. Now, if you ever box it up and you plug it in for the wrong variable, you'll know because you'll have both x and y, and you can't solve an equation with both x and y. So you want to make sure when you plug your box into the other equation that you have only all x's or you have all y's, and that's how you know you plugged it into the right place. Once you have plugged into the other equation and solved it, you'll plug your answer in to the boxed equation. And then you'll solve it. And then you'll have an answer that you write as an ordered pair. Okay, so let's take a look at this first example here. We have y equals 6x and we have 2x plus 3y equals 20. Is this a system? Yes. How do I know? There's two equations and they're both linear, so we have a linear system. So what I'm going to do is I'm going to box up this 6x because that's what y equals. And so the first step is to figure out your x or y equals and box it up. And because it's a y equals, I'm going to substitute it into the other equation for this y. So I always blob it out. I'm a very visual person, so I like to box stuff up and plug it into the blob. So I'm going to create an equation. It's going to be 2x plus 3 times, that y no longer exists, it is now the 6x, equals negative 20. So that should look very familiar. It's something you worked on last year. And now I'm going to solve this equation. So 3 times 6x is 18x. Combine like terms. Divide by 20 and you get negative 1. Most students at this point think they're finished, and you're not. Now we're at step 3 where it says plug answer into the box and solve. So I'm going to take this, and really you can plug it into either one of those two equations, but it's going to be easiest to plug it into the box because it's almost like ready for you to plug that in. And so when I plug that in, I get y equals 6 times my x value, which we found to be negative 1. And that gives me a negative 6. You have to write your answer as an ordered pair. And remember, your x comes first. So we found x to be a negative 1. And then my y we just found to be a negative 6. So that is my solution. So find your x or y equals, box it up, and plug it into the other equation. So let's take a look at another example. Let's have y equals 2x minus 2 and y equals x plus 2, because for whatever reason, whenever we see problems like this, students get confused. Again, I want to find the equation that's got the x or y equals, and in this case, both of them do. So does it matter who I box up? It does not. I'm just going to box up the top equation, and I know because it's y equals, I got to replace the y. So I'm going to black out that y or blob it out. And so now I'm ready to write my new equation. I'm going to substitute in the 2x minus 2 in for the y in the bottom equation. So that looks like 2x minus 2 equals x plus 2. Let that marinate in what you just did. And now I'm ready to solve. So I'm going to move my x by subtracting it. So I get 1x minus 2 equals 2. Add 2, and I get x equals 4. Now remember, you're not done. You're only halfway done. You got to take this answer and plug it into the boxed equation. Again, you could actually plug it into either, but I like to go into the boxed one because it's easier. So I get y equals 2 times x, we now know is 4, minus 2. 2 times 4 is 8, minus 2, you get 6. So my answer, remember your x goes first, and then your y. Okay, so that is how you use substitution. And those problems both were ready because they both had either an x or y equals. Let's take a look at an example that does not have an x or y equals. Oops, that's not what I wanted. All right, so if I have 2x minus 3y equals negative 24. My other equation is x plus 6y equals 18. Now, if you notice, I don't have an x or y equals. So what would you do in this case? You're going to find the equation that it would make easiest to find x or y equals. So if you want to, I always look for the problem with the leading coefficient of 1. So if you take a look at this bottom equation, look at that x. That x has an invisible 1 in the front, so that's going to be the easiest one to solve for. So to solve, I'm going to simply take my 6y and walk it over the equal sign, so it becomes a minus 6y. So this is now gone. And so what you have is x equals 18 minus 6y. So with that being said, I'm going to get rid of all this because that's no longer there. I now can box up the 18 minus 6y because it's the x by itself. And it's going to go in for the x because it's an x equals. So my equation would be 2. It goes in for the blob. So I could put 18 minus 6y, parentheses, minus 3y equals negative 24. Now I'm ready to solve. 18 times 2, 36. 2 times 6, negative 12, minus 3y equals negative 24. Combine your y variables, and that gives me negative 15y equals negative 24. Subtract the 36 to the other side, and that gives me negative 60. Divide by negative 15, and you get y equal to 4. Positive 4, because two negatives equal a positive. Are you done? Nope. Halfway there, plug that into the boxed equation. So x equals 18 minus 6y, we now know is 4. 18 minus 24. So x equals negative 6. Again, make sure you put your x answer first in the parentheses. It's always x comma y. So make sure if you do not already have an x equals or a y equals, look for the equation that's got the coefficient of a 1. Look for leading coefficient of 1. And that'll be the equation that you would solve for, just like we did on this example. And I want to show one that, let me see. Let's do this next one. I want to show you one of our special cases. I don't even know. Is that example number 4? Sure. All right, so here is y equals 2x plus 6 and 2x minus y equals negative 2. So who would I box up in this equation? That's right, the 2x plus 6. And again, that's a y equals, so I would plug that box in for that y. So I get 2x minus parentheses. Very important that you put the box stuff inside parentheses because you'll have to distribute. And in this problem, I would distribute that negative 1. So 2x minus 6 is what that turns into. Now when I go to combine my x terms, you'll notice 2x minus 2x cancels. So I'm left with negative 6 equals 2. And that's a false statement. And because it's a false statement, we say that my answer is no solution. Do you know what kind of lines those would have been if I have no solution? That's right, they would have been parallel. So just be careful, you'll end up with some special cases. And your special cases are if you have a false statement, it would be no solution. If I would have had something true, say I did all this work, on example number 5, I did all this work, and I ended up with 50 equals 50. And that's a true statement. So my solution would be infinitely many. What kind of lines are those? Those are going to be the lines that look like there's only one, but there's really two. They just sit on top of each other. So just be careful with your two special cases. If your variable gets lost, you cancel it out, it's gone. If it's a false statement, it's no solution. If it's a true statement, it's infinitely many. All right, and so that is substitution. And like I said, this should be a review. You did this last year in Math 1. But if you have any questions, please let me know. And just remember, on your Delta Math assignment, you are going to have to show me your work to get credit. If I don't see any work shown with the problems that you're doing, then you're not going to receive any credit. All right, let me know if you guys have any questions. Bye.